Yeah, you're clear now.
Okay, good. So let's take a look at number 2. Number 2 has to do with vocab. So when graphing, how do we translate our parent function of the cubed root? We're going h units in what direction? H units what way? So h is under the square root. So if something's under the square root, we're moving horizontally or vertically? Horizontally. I think I spelled that wrong, but it's fine. And then we're going k units vertically. So whatever we add or subtract outside, we move up or down. Whatever we add or subtract inside, we move left or right. All right, matching. +3 on the inside tells us we go which direction?
Left.
Left. So which graph tells us we're going to the left 3? B. +3 on the outside tells us we go which way? Up 3. So which graph tells us we go up 3? D. -3 on the inside tells us we go which way? Right. Which graph do we move right 3? F. -3 on the outside? Down 3. And which graph do we go down 3? A. And then 7. We have 2 transformations going on. A +3 on the inside, which we know is left, and a -3 on the outside, which is down. So which graph are we going left and down? E. And then this one we have a -3, which is right, and a +3, which is up. So which one are we going right and up? C. Any questions on that first part?
Yes.
All right, for 9 through 17, these 5 questions, we're graphing. For these, we have to plug in numbers, get our points on our graph, and plot the points. All the fun stuff. 9, we can see it only has one transformation happening to it, so we can take our parent function and move it which way? What does that +4 tell us?
Up 4.
We're going up 4. So this one I'm not going to plug in points, I'm just going to move it up 4. So instead of being at 0, 0, we go up 4. Draw our graph. What is our domain here? So what is our smallest x value? If we start all the way on the left side of our graph and go until we hit our graph, we hit our graph at 0. So our smallest x value is 0. And what's our biggest x value? Our graph goes forever in the right direction, so it's reaching all the x values over there. So what do we put? 0 to what? Infinity. And then our range is our y values, so we start at the bottom and go up until we hit our graph. We hit our graph at what point? 4. So our range goes from 4 to what? Infinity. So you don't have to draw like the green and yellow highlighted parts that I did. Those are just a way to think about it to help you find where your domain and your range start. All right, 11, we have more than just a shift of our transformation happening, so we need to plug in some points here to figure out what's going on. So number 11, we have negative cubed root of 2x. So what can we plug in first here? 0. Some good things to note when plugging in numbers for just our basic square roots. We like it when we have the square root of 0, the square root of 1, or the square root of 4, because all of these give us some nice whole numbers back. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So these are good numbers to get under the square root when plugging in. When you have the cubed root, some nice ones to have are 0, the cubed root of 1, and the cubed root of 8, because this will give us 0, 1, and 2. So if you want to plug in numbers to give you these numbers under the square root, these are good places to start. So if we plug in 0, we get 0 under the square root, which we like. There we go. So what do we get when we plug in 0 under our square root? 0. So our first point is going to be 0, 0. So we can go to our graph, plot our first point at 0, 0. For cubed root, we like to have negatives too. So another one for a cubed root would be -1, because this would give us -1. So just a little note there. Another additional one that we like to have under our square root when plugging numbers in. So we have 2 times x. What else can we plug in under for x? Since we have the cubed root, we want to plug in negative numbers too. We cannot forget about the negatives. -4. Because we said 8 was a nice number to have under, because that gives us a whole number back. So we have negative cubed root of 2 times -4. So this is the cubed root of -8. What's the cubed root of -8? -2. But that negative out front, so we have 2 negatives, negative, -2. What does that do to our 2? Because we still had a negative out front. So the cubed root of -8, we said was -2. But a negative out front means we have a double negative there. Negative -2. So what does that change our 2 to? A positive. So we're going to go to the left 4 and up 2. Put our point there. What else can we plug in? Awesome, 4. So we have negative cubed root of 2 times 4, which gives us -2. My connection's unstable again, so let me know if you guys can't hear me. So we're going to go to the right 4 and down 2. Once we have our 3 points, we can go ahead and draw our cubed root graph. So remember that graph has a curve to it. So it's going to look like this. Kind of. We just need our graph to have that curve. There we go. It's a little bit better. Alright, so what is our domain here? What's our smallest x value? we're going forever in the left direction. All real numbers. So we're going forever in the left direction, forever in the right direction. Our domain is all real numbers. Sandeep, you asked this question yesterday. Is it always going to be all real numbers for cubed root? And the answer is yes.
Okay, thank you.
So domain and range, anytime you have a cubed root, our domain and range are all real numbers. So any single time you have a cubed root, so that index of 3, you have all real numbers. The only time you got to think about what your domain and range might be is when you have a square root or a fourth root. Any questions on this one? 11. Ready for 13? So for 13, we have 1/5 square root x minus 3. So we're going to plug in values for x, get numbers for y, so we have x comma y. So a helpful hint on where to start plugging numbers in, since we like to start with whatever is 0 underneath our radical, so whether it's cubed root or a square root, we want to set what's under the radical equal to 0. So x minus 3 is equal to 0. So this will tell us where to start. So to solve for x, we add 3 to both sides. So x is equal to 3. We want to plug in 3 first. So let's plug in 3. So typically we've plugged in 0 first. If we plug in 0 here, we would get 0 minus 3, which is negative 3. We can't have a negative under the square root. So if we plug in 3, we get the square root of 0, which is perfect. Because we can't have anything smaller than that. Because we can't have negatives under a square root. So we have 1/5 times the square root of 3 minus 3. So 1/5 times the square root of 0, which is 0. 1/5 times 0 is 0. So our first point's 3, comma, 0. Go to our graph. We go up 3, stay on 0. What should we plug in next? So we said we like to get 0 under our square root. We like to have a 1 under our square root or a 4 under the square root. So what should we plug in for x to get a 1 under the square root? 4. So we have 1/5 times the square root of 4 minus 3. So 1/5 times the square root of 1, which is just 1/5 times 1, so 1/5. So 4 comma 1/5. So we're going to go to the right 4. Oops, I put this point on the wrong spot. We go to the right, not up. So we go to the right 3 and stay on 0. Our next point is at 0, as at 4 1/5. So we go to 4 and go up 1/5. So we are just barely off the ground there. What else can we plug in? 7. So we have 1/5 times the square root of 7 minus 3. So 1/5 times the square root of 4. What's the square root of 4? 2. And what's 1/5 times 2? 1/5 times 2 would be 2/5. So we have 7 comma 2/5. So we're going to go to the right 7, and then we go up 2/5. So 1, 2, 3, 4, 5, 6, 7, up 2/5. So still barely off the ground. And then we just draw our curve. So what is our domain here? what's our smallest x value? So if we start at the farthest left side, look at all of our x values, where does our graph start? 3.
3.
So our domain starts at 3 and goes to
Infinity.
infinity. All right, now let's look at our y values. So y values, where does our graph start? Where do we first touch our graph?
0.
0 and go to
Infinity.
infinity. Good job. Any questions on this one? So 15, I'm running out of space. We'll do it down here. Is 6x to the 1/2 power plus 3. What do we know about that 1/2 power? What does that change to? One half.
Square root.
Awesome. 1/2 power is the same thing as the square root. So the square root of 6x plus 3. So we're dealing with the square root graph. So we plug in numbers for x, get numbers for y, so we have our points. So what should we plug in for x first?
Zero.
0. Awesome. We can't have any negative numbers here, so we want to start with 0. So you have the square root of 6 times 0 plus 3. 6 times 0 is 0. Square root of 0 is 0. And 0 plus 3 is 3. So here we have 0, 3. So we stay on 0 and go up 3. What else can we plug in?
How do you know when you can't use negatives or not?
When you have a square root, you can't have any negatives under it. If you have the cubed root, you can have negatives. So you can't have negatives under the square root.
Alright.
Good question. What can we plug in next?
1.
We can plug in 1. This one's kind of tricky because we're going to be plugging in big numbers to get whole numbers because we're multiplying it by 6. But we could just use a calculator for this one if you needed to. So what's the square root of 6? .44. So let's just say 2.4. So 2.4 plus 3 would be 5.4. So we have 1, 5.4. So we're going to go to the right 1 and go up 5.4. What else can we plug in? Let's plug in 2. So we have 6 times 2 plus 3. So when we plug in 2, we have the square root of 12. So the square root of 12 is 3.4. And 3.4 plus 3 would be 6.4. So we plug in 2, we get 6.4. Now in the last class when I did this problem, we plugged in 6 because 6 times 6 under our square root was 6. So when we plugged in 6, we got 9. So you can plug in anything you want. It's best to plug in numbers that'll give you a whole number because then you don't even have to use your calculator. But if you have a calculator handy, we can plug in whatever. So we have our 3 points. We draw our curve. What's our domain and what's our range? So what's our domain?
0 and infinity.
Please let the women's JV basketball lead to.
So 0 to infinity, and then what's our range?
3 to infinity.
Awesome. Our smallest y value is 3, so we go 3 to infinity. Any questions on this one? So let's do 17. So 17 is the negative fourth root of x. So we're going to plug in numbers for x, get numbers for y, and have our points. So here we have the fourth root. We haven't done fourth root before. Do you think we can have negatives under the fourth root? Nope. Because 4 is an even number. Can't take the fourth root of a negative. So just like we can't take the square root of a negative, can't take the fourth root of it either. Because 4 is even. So we wouldn't have any real zeros there. So what can we plug in first?
0.
0. So when we plug in 0, we get 0, so our first point 0, 0. What can we plug in next? Awesome. Plug in 1. So when we plug in 1, we have the negative fourth root of 1. What's the fourth root of 1?
1.
1. And then that negative makes it a negative 1. So when we plug in 1, we get negative 1. So we're going to do the right one and down 1. What can we plug in next? Anything.
2.
2. Sure. So we have the negative fourth root of 2. We don't know what the fourth root of 2 is, but we can definitely put it into our calculator. So the fourth root of 2, which is 1.189. So this would be negative 1.1. We can round it to 1.2 since it's closer to 1.2. So we plugged in 2 and got negative 1.2. So let's go to our graph. We plugged in 2, got negative 1.2, which is just past 1. So our graph looks like this. So the fourth root graph is very similar to the square root graph, but it just takes longer for it to get up. So it's kind of just like flatter than the square root. So what is our domain? What's our smallest?
0 to infinity.
Awesome. Our smallest x value is 0. We go to infinity. And what about our range?
Infinity to 0.
So our graph goes forever in the negative direction. So you want to try again? What do you think? It's not infinity to 0. Because what's our smallest y value if it goes forever in the negative direction? It would be positive infinity if it goes up. What about if it goes down? Negative infinity. So we go negative infinity because that's our smallest y value. And then our biggest y value is 0. So negative infinity to 0. Alright, the last few are a breeze because all we have to do is translate them from the parent function. So if we have our parent function, that looks like this. For 19, What does the plus 1 do to our graph? Plus 1 on the inside.
Move it left.
Left 1. And what about the plus 8? Up 8. Because plus 8's on the outside. So plus means we go up. So we're going up 8. So we are going to go to the left 1. So we take this point, move it to the left 1, and move it up 8. Put our new point there, and our new graph goes this way. So describing our transformation, we just say it goes to the left 1 and up 8. And then this is our graph of our new function, g of x. The next one, we have square root again, so I'm going to do it on the same blue graph here. I'm going to change the color of this graph. So what does the minus 1 on the inside tell us?
Right one.
Awesome, right one. So we just take our blue graph, shift it to the right one, and draw our curve that way. Next, we have the cubed root graph for 21 and 22. So our parent function of the curve of the cubed root goes in the negative and the positive direction. So we have a minus out front. So what does this negative out front tell us?
It's a reflection.
A reflection. On the x-axis or y-axis?
X-axis.
The x-axis. And what about the minus 1 on the outside? Down 1. So we flip it on the x-axis. So since this is our x-axis, we just flip it. And then we take that and shift it down. If this was Notability, I would just highlight it and shift it down, but it's not. So I just have to redraw it. But we just shift it down 1. So that's our new graph. I'm going to do the next one since it's cubed on the same graph. Just pick a new color. So what does the plus 4 on the inside tell us?
To the left 4.
Left 4. A minus 5 on the outside?
Down 5.
Down 5. So we're going to shift our parent function to the left 4 and down 5. So that's our new center point, and then we just keep the same shape of the blue one. So it looks like that. Any questions so far? Alright, almost done. So next we have the square root graph. Our square root parent function goes this way. So if we have a negative x to the 1/2 power, what transformation happens with a negative being multiplied on the inside? A reflection on the y. So our y-axis is this one, so we have to flip it across the y-axis. So it flips to this way. Right, for 24, we have the cubed root, so we have that curvy looking one here. What does this plus 6 tell us?
It
up 6. So 1, 2, 3, 4, 5, 6. Draw our graph through here. Alright, and last one we have the fourth root. We said the fourth root looks just like the square root, but just a little bit flatter. So what does the plus 5 tell us on the inside? It goes left 5. And then minus 4. Down 4. So we go to the left 5. Down 4. Put our point there. That's our graph. Alright, what is our error in graphing? F of x is equal to the square root of x minus 2 minus 2. What does this minus 2 on the inside tell us? To the right 2. Does our graph look like it went to the right 2? No. So that's our error. They went left, we were supposed to go right.